continuing on in 7.5, and it says, sometimes the difference of two squares. So in other words, you look at it, you see that it's a binomial, you see that there's subtraction, you see that there's squares. Well, there might be squares on both ends of it. Sometimes it's not a quadratic binomial. Yesterday, all those binomials we did were quadratic. Quadratic means what? You think it would because it's quad, but it means degree. It's not degree. Quartic is degree 4. Degree 3? No, 2. X squared. Remember it was x squared a lot yesterday? They were quadratic, or a squared, or y squared, or whatever it was. All of the ones we did yesterday were quadratic. So the square root of x squared is? X. Square root of m squared is? M. So if it's quadratic, that's pretty easy. You're just like, oh, I know what the square root of that is. Well, sometimes they're not going to be the quadratic binomial, but rather a binomial that's of a different degree. So examples, x to the 4th minus x to the 10th. X to the 6th minus y squared. 9x squared minus 4y squared. So let's review what happens when you multiply powers with the same base. What happens when you have a power times a power and they're both the same base? So like 3 squared times 3 cubed. What do you do with the exponents? Add them, don't you? Yeah, because you got 2 factors of 3 in 3 squared. You have 3 factors of 3 in 3 cubed. So you say, when I'm multiplying them, I now have 2 3's and 3 more 3's. I have 5 altogether, so 2 plus 3. So remember, we add the exponents when we are taking a power times a power with the same base. So let's practice that again. What's x cubed times x cubed?
X to the 6th.
X to the 6th. What's y to the 4th times y to the 4th?
Y to the 16th.
Y to the 8th. We add them. What's z to the 5th times z to the 5th? Z to the 10th. Yeah, z to the 10th. Add the exponents, and the base is the same, and you're multiplying. Just add their exponents, and you will have your simplified, your product. Okay, therefore then, if x cubed times x cubed is x to the 6th, what's the square root of x to the 6th?
X to the 3rd.
X to the 3rd. It's asking the same question. What times itself? Square root means what times itself gives you that radicand, that x to the 6th. Well then, what's the square root of y to the 8th?
Y to the 4th.
Y to the 4th. Well then, what's the square root of z to the 10th? What times itself is z to the 10th? Z to the 5th. So notice what happened here. We learned that to take a power times a power, you just add the exponents if they have the same base. So even yesterday, when you guys were taking the square root of x squared, you did not even think to yourself, how do I get it? You just automatically said the square root of x squared is x. What is x? What power is x to? Second power? X? First power. I just say x. That is to the first power. So is x to the first power times x to the first power? 1 plus 1 is 2, isn't it? So if I have x to the 3rd power times x to the 3rd power, that is x to the 6th power. So now when I'm asking for the square root of x to the 6th, I'm asking for what times itself gives you x to the 6th. X to the 3rd times x to the 3rd. So could you tell me something? Notice, what relationship do 6 and 3 have? 8 and 4, 10 and 5?
They're half of it.
Half of it. So if you're finding the square root of something to the 10th power, you just say 10 divided by 2 is 5. If you're finding the square root of something...
Mrs. LeGrand?
Yes?
Will you have Malcolm go to the junior high office?
Okay.
Thank you.
So if I ask you what is the square root of y to the 16th, what would it be?
8.
8. Y to the 8th, because 16 divided by 2 is 8, because 8 plus 8 is 16. Okay, how about the square root of n to the 20th?
Sure.
That'd be 10, wouldn't it? Yeah, n to the 10th power, 20 divided by 2, I need it, because I gotta add 10 to itself, I'll get 20. Okay, so what do you think? Does the exponent have to be a perfect square for the power to be a perfect square?
No.
Because look at, is x to the 6th, is 6 a perfect square?
No.
No. Y to the 8th, is 8 a perfect square? No. Z to the 10, is 10 a perfect square? No. So does the exponent have to be a perfect square for the power to be a perfect square? No. So we don't have to look for perfect square exponents. What we have to look for is something else. What do you think the exponent has to be? Can you come up with, after, what we just kind of talked about here, do you think? Even? Did I hear? Because why? Why do you think it would have to be evenizing? I like that idea.
Because if it's odd, then it's not gonna have two things to, like, two same numbers to equal the odd number.
Yeah, you can't add up two of the same thing and get an odd, can you? I mean, go ahead and try. Can you add up something that's an integer that gets you 3? That's, something added to itself, that's an integer that will give you 3.
Yeah.
How about 9? Can you add anything to itself that's an integer
You can multiply.
that will give you 9? And we're adding them, remember, because we add powers for.
6 and 3.
So I think it sounds kind of like Dicey's got a really good idea. That power, that exponent's going to have to be an even number. So let's put that. The exponent will have to be an even number. Doesn't have to be a perfect square, but it will have to be an even number because remember we want it divisible by 2. 9 isn't divisible by 2 and get an integer. 3 isn't divisible by 2 and get an integer. Okay, so I want you now, you have a pencil in your hand, right?
Yep.
I want you to circle the monomials that you think are perfect squares up there. Go ahead and just try it. Which of those, if they show up in our binomials, would we say they are perfect squares? Go ahead and try it. It's going to be important that we can recognize perfect square monomials to help us determine if we can factor our binomials today. Yesterday was pretty easy, we just had to look at the number part. Okay, now I want you to compare your list with your table partner, and Cameron, you can turn around and share with Isaac and Josh there. Let's see if you guys agree. What do you think? Okay, and now if I tell you there are 5 of them that you should have circled. Only 5. Or maybe you don't have enough. Some of you, I think you have a lot more than 5 circled. Some of you might not have enough circled. 5 of them are perfect square monomials. You think you got 5? Okay. Now, you want to circle around there and see if we all agree with you? You just use your finger and circle around the ones that you say are perfect square monomials, and then they can decide if they're going to agree with you. Okay, Cameron says it's those 5, because I said it was 5. How many of you agree with Cameron that those are the 5 that should be circled? Only one, are you the only one who's gonna agree with them? Yeah. 8 opposite corners of the room.
I think so, yeah.
Yeah?
That's
Okay.
what I'm guessing. Thinking.
Okay. Well, let's go through and evaluate why or why not some of these are. How about x to the 9? Why isn't it? Cam says it's not. Why wouldn't it be?
Exponent.
Exponent is an odd number. As soon as you see an odd number exponent, you say to yourself, I cannot take the square root of that. I can't. Okay, so that one shouldn't be circled. Y to the 4th? You all agree with y to the 4th? Yeah, what would the square root of y to the 4th be?
It's y squared.
Y squared. 2 plus 2 is 4. Y squared times y squared would be y to the 4th. So y to the 4th does qualify. How about z to the 12th? Yeah, what's the square root of z to the 12th? Z to the 6th. Z to the 6th times z to the 6th, 6 plus 6 is 12. Okay, we're going to keep that one circled. How about 4x to the 6th? Is 4 a perfect square? Yes. Is x to the 6th the perfect square? Yes. So what would be the square root of 4x to the 6th? 2x to the 3rd. Yeah, the square root of 4 is 2. The square root of x to the 6th is x to the 3rd. So 2x to the 3rd would be the square root of 4x to the 6th. Well, Cam did not circle 2y to the 8th. Why not? What part is it? What? The 2. Is 2 a perfect square? No. The y to the 8th is, isn't it? But the 2 is not. Both the number part and the variable part have to be perfect squares. 16z to the 9th. What's the problem with that one?
9.
The 9. Its exponent is odd. 81x to the 10th. Is 81 a perfect square?
Yes.
Yeah. Is x to the 10th a perfect square?
Yes.
Yes. What's the square root of 81x to the 10th then?
9x to the 5th.
9x to the 5th would be the square root of that one. What's wrong with 4y to the 25th power?
The 25.
It's 25. There's not power again. You can't add something to itself and get 25. 36z to the 16th. Is 36 a perfect square?
Yes.
Is z to the 16th a perfect square?
Yes.
Okay, then what's the square root of 36z to the 16th?
6
6
To the 4.
z to the 8th, because remember in these you add, not multiply. So 8 plus 8 is 16, so it'd be 6z to the 8th. It's a little confusing because when we take the square root of a number, we have to look for what times itself. Here we have to look in the variable one, we have to look for what plus itself gets you there. 72x to the 4th, what's wrong with that one? 72, is that a perfect square? No, 72 is not a perfect square. The x to the 4th is, but the 72 is not. So those are the 5 that should be circled as perfect square monomials. Okay, anybody want to ask questions about any of those before we move on? Okay, now we've set ourselves up for being able to do these. Let's go. Factor if possible. We're going to do the same thing we did yesterday. Does it have subtraction? That's the first question you ask yourself. Does it have subtraction? Yes, it is subtraction. So now we can go to finding the square root of the two terms. So the square root of x to the 4th, the square root of x to the 10th. What is the square root of x to the 4th? X to the 2nd. 2 plus 2 is 4. What is the square root of x to the 10th?
X to the 5th.
X to the 5th. 5 plus 5 is 10. Now remember, just like yesterday, both of our factors start with the square root of the first one, so both of them will start with x squared. Both of them will end with
X to the 5th.
x to the 5th. One will have subtraction and the other will have addition.
Does it matter?
No, it does not matter which one, because they both have the same beginning and ending terms. Okay, anyone want to ask about that one? Yes, right.
So, what would happen if we didn't write with x to the 2nd first, and we wrote with x to the 5th first?
Then it would throw it off. You would throw it out, because what would end up happening is after you boiled it back out and cleaned it up, it would turn out as x to the 10th minus x to the 4th. Does that mean the same thing? No. So you can't change those guys around with that. Okay? Good question. Any others? Any other questions on this? Okay, this is the kind of work you need to show. So, okay, number 2. First thing you always ask yourself, first thing you always ask yourself is what? Is there subtraction? Don't get caught doing a whole bunch of work when it's addition. So it's subtraction. So we say, okay, well then I can move on and I can take the square root of x to the 6th if I can.
Is
What is it?
3, x to the 3rd.
X to the 3rd, because 3 plus 3 is 6.
I'm confused about the y too. Like, is that factorial?
Is y squared a perfect square?
Yes.
What's its square root?
Why?
Y. Or y to the first. We don't have to write the 1, but it's, you can, it wouldn't be the end of the world, but you won't see it written. 1 plus 1 is 2, there's an invisible 1 there. So
Yeah.
now, both of the factors start with what?
X to the 3rd.
X to the 3rd. And both end with
Why?
y. One has addition, the other has subtraction. Okay, questions on that one? Okay, number 3. First question,
Is it, subtract?
is it subtraction? Is it?
Yes.
Okay, so we go to trying then to take square roots. We say, do we have perfect squares here? Can we take the square root of 9x squared?
Yes.
What is it?
3x.
3,
3x.
3x. Square root of 9 is 3, square root of x squared is x. Now we tried the square root of 4y squared. Can we take the square root of that?
Yeah,
Yes.
2y.
And that's 2y, okay? So we could square root both of them, so we're ready to set up our 2 binomial factors. They both start with 3x. They both end with 2y. One has addition, the other has subtraction. Okay, I want you to try number 4 on your own. First question? Okay. So, what is the square root of 1, class?
1.
1. Oh, that was a weak class. I got 1 person in this class. What's the square root of 9y to the 4th, class?
3y to the 2nd.
Well, it's getting a little, more populated. I'm up to 2 people. 3y squared. Okay, here's the rule. This road is not going to answer me anymore because you're the only ones that have your tongues working today and brains with them. You guys are on the hot seat, okay? So both factors are going to start with 1. Both factors are going to end with 3y squared. Good job, way to come through. And one's going to have addition, the other's going to have subtraction. Does the order matter there? Do they have to start with that 1?
Yes.
Yes, they do. They have to start with the 1 and end with the 3y squared because of the order they were in the binomial to start with. Okay? Questions on that one at all? Number 5. First question I'm going to ask Riley is what in number 5? To myself, I'm going to say, is it?
Factorable.
Yeah, that's what that is. That's the main goal. Is it factorable? But what's the very first question is going to help lead me there? Is it?
Say subtraction.
Oh, thanks for helping them out, Juan. Is it subtraction? It is, isn't it?
It is.
Okay. Right. Number 5. There's a subtraction right there. So now we're going to say I can go to work then, seeing if I can take the square root of the terms. Can we take the square root of 25x squared?
No,
Yeah,
It's
5.
Yeah, 25 is a perfect square. 2 is an even number. Remember, that's what we look for. If the number in front, that's not the exponent, is a perfect square, and is the exponent even. So square root of 25 is 5. Square root of x squared is x. We can do it. Then we try the other one. 4x to the 6th.
So,
Can we take the square root of 4x to the 6th?
yes,
Yes, do it.
twice to the third.
2x to the 3rd. Isaac, you're...
this is the
Square root of 4 is 2. Square root of x to the 6th is 2x cubed. Yes, Sharky.
I'm confused, like, on the adding part, so like, say it's like the 25 was 20, and then what would it be?
If the 25 was 20 in that one,
Yeah.
20x squared, then we'd have to say, we would put the square root symbol around 20x squared, and we'd say behind that, can't do, because 20 is not a perfect square.
So it only goes for the, like, the x's, so like, it feels like,
Right.
x to the 20th, like, then it would be x 10, right?
Then you could,
Alright.
then you could. Okay, so our factors are gonna both start with what class?
5x.
5x. I got a one-person class again. Our factors are gonna both end with
2x to the 3rd.
2x to the 3rd. And one will have addition, the other will have subtraction. Okay. Questions on number 5? Still lingering out there. Okay, number 6. First question you ask is?
It's a subtraction.
Is it?
No.
No. So here's what you can do, guys. Circle that and say, not factorable. And the crazy thing with this one is it starts with a perfect square and it ends with a perfect square, but that addition stops us from being able to factor it. No sense trying to find the square root of either of those. Okay, how about number 7? Number 7. Cameron?
Not factorable.
Why not? It's got subtraction.
But the 2 is not an equal square.
It's not a perfect square? Okay, so this is the part. If we try to take the square root of 2y to the 8th, can't do, right? We can take the square root of the y to the 8th part, but we can't take the square root of 2 and get a nice integer. So we're going to say this one is not factorable either. Okay? So we're doing the same thing we did yesterday, it's just we expanded it to being other than quadratic binomials. And having to keep straight now, how do you take the square root of something that is not quadratic? Or when can you take the square root? So any questions you still have out there? Okay.